So in this example, we'll see how to use SparkML library, and specifically we will use linear regression algorithm to demonstrate them. So for that, you need to use this artifact for your library dependencies, SparkML lib and 3.0.0 version. Okay. This is a stable one. So as you know that linear regression is fitting line onto a data set, and once you have the best fit line for a set of observations, you can predict new values, right? So this is quite straightforward for two-dimensional space, and for multi-dimensional space, SparkML library uses uh, stochastic gradient descent or SGD. So uh, it's kind of friendlier because it looks for contours in higher dimensions, and so it relatively finds the sort of best fit lines across this multidimensional space for you, right? So once you have the linear regression model set up and configured, you just train your model and make predictions using tuples that consists of a label and a vector of features that you are using to predict the label. So that we'll see shortly how to actually use the most out of it, and then how to use these features essentially. Okay. So just the thing you need to remember is that in that case, the label would be the value you are trying to predict. Okay, and usually we frame that as our y-axis, and a feature is your x-axis, right? Or other axis if you have multi-dimensional space. So there are some gotchas in SGD, and that we'll see how to actually tackle that. Basically, SGD is not suitable for handling feature scaling well, right? So it assumes your data is similar to normal distribution. So if it is not, you need to scale your data down to fit within a range that is more comparable to standard bell curve, and back up again when you are done. Okay, so that is kind of uh, another problem in using SGD, and that's why feature engineering is kind of essential for running machine learning jobs, right? So you are all aware of these kind of things, and we'll just uh, jump into the problem here. Okay, so first take a look at the data set we are using for this setup. So this is fabricated data for page speed and revenue generated from session data or for an online store. Okay. So the problem is that can we predict revenues? So this first column is for the revenues and second column is for your average page speed. Okay. So you are trying to predict the revenue, that means the amount spent depending on the or based on the page speed uh, for this particular session. Okay. So the second column represents the page speed and the first column represents the revenue generated. So here, as you can see, amount spent, and both the amount spent and the average speed is kind of scaled down to fit into a normal distribution. As you can see, of course, this minus negative does not mean that it is kind of negatively amount spent. So this is just scaled down data, okay, to fit the curve. So often you need to actually scale down the raw data. So this is not exactly raw data you are using. This is the scale down data or feature engineered data that you are using here. So first column is the amount spent, and the second column is the feature the feature we are using to predict that amount spent, which is the average speed. Okay, so here we have one feature and label as the amount spent or revenue generated. So we are trying to predict that label, that amount spent depending on the feature page speed. Okay, so with that we will just go to the code here. So the object name is linear regression dataset. So we'll be using dataset and data frame extensively to actually spread out the jobs across the clustered nodes we have. So this is the main gist or crux of this exercise. So first we have imported all the necessary packages, as you can see, and then we have spark up the log level, spark up the spark session, and then so well, here we have actually created the case class regression schema that is actually used to read your data set. So here we have the label as double and the feature raw as double also. So both the columns as double and double. So we are using this regression schema for the data set. And for the data frame, we are creating this struct type schema as label and feature row. So these both fields are similar to as the regression schema case class as here. Okay, so that will be that we will be using to read the regression.txt, which is residing inside the data folder here. And as you can see that we are using this separated comma separated file. So option separation is comma. So with this, we have generated this DS raw as the dataset uh, uh, for our training and test data we will be using from this. But for now, we have just set up the dataset here. And to use the regression model, here what we mention that when you will be using a particular model, you need to see how to use the model inside the Spark, and that's how you will use a linear regression model here inside Spark. So first you have to create the assembler where you need to actually gather all the feature, and then you need to assemble all the feature to our output feature that we'll give here as features. So what we are doing here, we are creating this assembler. So vector assembler is the object, and we are taking these input columns. So as I said, this linear regression here works for multidimensional space, but here we have only one feature, that is features raw, and that you can give inside the array features raw. So it will take all the columns as an array object where you have multiple features defined. Here we have only one feature, that is features raw. If you have multiple features in your multidimensional space, you can actually define or add all the features here. Okay, and for the assembling, we will give the output to features. Okay, so this will take all the features as input and output one single feature as your defined column name here. So next is to transform the raw dataset which we have created from the dataset file to the expected or desired kind of setup. So here we have the label as the label feature and the features as the feature which is transformed from this dataset. Okay, through this assembler. So we have created this data frame as label and features. So label we are going to predict depending on this or based on this feature. Okay. So now next is to create the training and test data set. So often machine learning algorithms are subjected to evaluating the performance of the model. So here for that, you need to create the training and test data set. And here we are creating this training and test data set by splitting the entire data frame half to for training data set and test data set as well. So here we are taking random split for this to split it by 50%, 50% for the training data frame and test data frame. Okay. So next is to create the model. Okay. Here we are generating the linear regression model as LIR, which is the new linear regression object. And here you need to set up or configure all the hyperparameters, such as for your linear regression, we have regularization, elastic net mixing, maximum iteration, convergence tolerance. So all these hyperparameters, you need to actually define that. And for that, so these values are kind of taken from your example data set here. But the essential thing to mention here is that those hyperparameters are not fixed for the entire problem you will be solving. So depending on the data set or depending on the model you are targeting, you need to actually try and set up new hyperparameters for to see whether you are getting better results or not. So this is kind of trial and error method you will be approaching to actually see which hyperparameters will give you the better result. Okay. So next is to train the model using the training data set which we have created before. Okay, here the half of the randomly split data frame. So here we are taking that into the model and fitting that training data set. So here the trained model is the model name, and we will use that model to actually predict the test data frame. So from the test data frame, we are actually transforming that prediction into full predictions. And after that, you will be taking that uh, full prediction, which is the predicted value from the labels. We'll just take the predictions and the label, which is the actual result or actual value from this data set. We'll take and print this out to see how it is predicted. And you can take this exercise to actually compare and see how much good the prediction is. So now here for the full prediction or for the prediction result, as you can see, we have cached that result. So that is common practice for actually take the predictions into the cache, because you'll be using repeatedly these full predictions for, let's say, testing your performance, giving some or extracting some prediction results. So it is good practice to actually cache them out. So that you can repeatedly use without any memory transactions. Okay. So at the end, we have collected these results, okay, inside your driver script, and then we have just printed that out. So let's see how it works. Well, here is the predicted values and the actual values which are present in your test data. So you can have a look into that and see how it has predicted. Well, so that's it for the linear regression, and we'll move towards the next exercise.